So I'm going to show you how to calculate the percent composition of a compound, and we're going to look at specifically how to do that from the chemical formula. So sometimes you'll be given a chemical formula of a compound and asked to calculate the percent composition of that. So before we do that, a percentage of anything, so anything you want to take a percentage of, it's always going to be a part of something divided by the whole amount and then times by 100. That is just the general formula for calculating a percentage. So we're going to keep that in mind as we do that. So let's say we want to calculate the percent composition of ammonium sulfate, and here's the formula for that. So what we need to do is calculate the percentage of the mass of each of the elements in the compound. So we have nitrogen, we have hydrogen, we have sulfur, and we have oxygen. So we essentially want to know what percentage of the mass of the whole thing is made up of just those elements. So I'm always going to start by making a list of what I have. So I have nitrogen, I have hydrogen, I have sulfur, and I have oxygen. And so what we need to do is figure out the mass of those individual elements that are in the compound and also the mass of the total mass of the whole compound. So I'm going to make a separate little spot to figure out the total mass. So we are going to need a periodic table to get our masses from. So I have one right here. So let's start with nitrogen. So nitrogen, we know on the periodic table has a molar mass of 14.01. So I'm going to add that in here. So I know that nitrogen has a mass of 14.01. I can also look up the mass of hydrogen on the periodic table, and I would see that it is 1.008. Sulfur, I can look up and find out that it is 32.07. And if I look up oxygen, I'll find out that it is 16.00. So those are the molar masses of each of those elements. But we have to remember that in our chemical formula, we have these subscripts. So we have a 4 right here. We have a 2 right here. We have a 4 right here. So those are telling us things, right? So this 4 on the end is telling us that we have 4 oxygens. So my number for oxygen, I'm going to have to multiply by 4. This 4 on the hydrogen is telling us that there's 4 hydrogens. But we also have this 2 on the outside, and we have to remember that that 2 is telling us that we're going to multiply, we're going to distribute that 2 by everything inside the parentheses. So what that means is we have 2 nitrogens, and instead of 4 hydrogens, we actually are going to have 8 hydrogens. Sulfur, we only have 1 of those. So let's get those totals added up. So 14.01 times 2 is going to be 28.02. So that's how much nitrogen we have in the compound. And if we do 1.008 times 8, that's going to give us 8.064. Our sulfur, we don't have to multiply by anything, and then 16 times 4 is going to give us 64. So we have our total amounts of each of the elements. We can use that to figure out a total for the whole compound, and we're going to do that just by adding them together. So 64 plus 32.07 plus 8.064 plus 28.02. That gives us a grand total of 132.154. So that is the total. So remember, when we do a part divided by a whole, that's going to be the whole. We just figured out what the whole is. So now we have to figure out what the parts are going to be. But we actually already did that. So each of these numbers are telling us the individual masses of each of the elements. So if we want to figure out our percentage of nitrogen, all we have to do is take that number we just figured out, 28.02, divided by our total, which is 132.154, and we're going to times that number by 100. 28.02 divided by 132.154 times by 100 is going to give us 21.2. And that would be our percentage. Let me rewrite that. That would be our percentage of nitrogen. So this compound is 21.2% nitrogen. So we'll go on to hydrogen next. So if we want to figure out our percentage of hydrogen, we're going to do 8.064 divided by that same total amount. 8.064 divided by 132.154 times 100. And that's going to give us 6.1% hydrogen. So these are going to have a lot of answers. We'll do our sulfur next. So percentage of sulfur, we're going to take that 32.07 divided by 132.154 and times that by 100. And that gives us 24.3% sulfur. So you can see I'm kind of just rounding these to one decimal place. That's plenty for these. And then lastly, we have our percentage of oxygen. So I'm running out of room here, but we have 64 divided by 132.154 times 100 again. And that gives us a total of 48.4% oxygen. So what we have now is 4 percentages. Those all 4 would be our answers, and we can kind of double check and make sure that these should equal 100%. So remember, percentages should always add up to equal 100. So if I add 21.2 plus 6.1 plus 24.3 plus 48.4, that does give me 100%. Sometimes you might get 99 or 101. That is okay. Whoa, that was crazy. That is okay if that happens, as long as it is close to 100. That just means your rounding was off a little bit somewhere, which is totally fine. But that is how you calculate the percent composition from a chemical formula.